Welcome back to another Project O Facebook Live. Thank you for sticking with us. We had a few technical difficulties this morning, so we are here a little late. I'm sorry. So today we are going to be learning about something that's fundamental in Long Island Sound and just in biology in general. We're going to be learning about density, and we're going to be doing a pretty cool, I think it's cool, experiment that kind of demonstrates that, and I'm going to ask you guys to follow along at home. So at some point, if you get a paper and a pencil, that would probably be very helpful. If you have any questions throughout the course of this video or even afterwards, feel free to put them in the comments below, and we will try our best to either answer them during the video or after the video has ended. Just a reminder, we are going to be doing these Facebook Lives every Tuesday and Thursday at 9:30, and we might do some kind of special ones in between as well. So a special shout out this morning to all of our students and teachers that are watching. Thank you guys very much. And a special shout out to, I want to get this right, McKinley STEAM Academy Magnet School all the way from Cedar Rapids, Iowa. So thank you guys. If you guys are watching, feel free to write in the comments where you all are watching from today so we can give you guys a shout out. So back to our lovely friend density. So if you know what density is, go ahead and hit that like or heart button so that we kind of have an idea. But if you don't, I want to go through it really quick before we get to our experiment. So I wrote here the formula for density. It is mass over volume, and or M over V. So before we talk about what density is, I want to break down the mass and the volume for you. So volume, if you guys have ever been baking, I know I like to bake a lot with my family or just on my own. But if you use a measuring spoon or a cup to measure, say, flour or sugar, you are actually measuring the volume of that substance. So for mass, it's very similar to weight, but there's one big difference, and it has to do with the fact of gravity. So mass doesn't take gravity into account, whereas weight does. So for instance, we have a lot of gravity here on the Earth, but not as much on the moon. So if you are on Earth, your mass and your weight are actually the same. But say an astronaut is out on the moon, their mass would be the same as it would be on Earth, but their weight would be much, much less because there's much less gravity there. And that's why you can kind of see them bouncing around off of the ground, because there's not gravity holding them down to the ground. So density kind of has to do with both of those things. So it's how much stuff or mass is in a given space or volume. So for instance, this morning, I have some props. I have two different balls. So this one is a ping pong ball, and this one is a golf ball. So they're the same size, but they have very different masses, and we're going to kind of see those in action today. So I want to get to our materials that we're going to need for our experiment. If you're going to try this at home, which I recommend that you do after this, we can kind of tell you how to pare it down a little bit. So if you have like a jar or even a cup at home, I like to use a glass one so you can see through it. So that'd be the first step that you need. Today, I'm going to be using this glass vessel, I don't know exactly what you'd call it, as what I'm going to be using. You also are going to need some syrup. I have some corn syrup with me today. Oops, sorry. I have some corn syrup with me today. I like to use corn syrup for this because it's going to be very clear, so you'll see how I'm going to need it to be clear in a minute. I have some oil, so any type of oil will do. And I have some water, which I have colored my favorite color, which is blue. Okay, so what we're going to do is we're going to start to put this together. And I want you guys, if you have that pencil and paper out, to kind of make some observations as we're going along. So we are going to be advanced scientists today, so we are going to make some predictions, and we're going to record our observations as well. So I want to start by pouring my water in first. See if I have enough here. Woo. So the main reason that I want to make it blue is just so that we can have a clear definition between the layers that we're going to be making. So you can choose any color, food coloring that you have at home, or if you need to, you can just leave it clear as well. So the next step that I'm going to do is I'm going to add some of my corn syrup. So let's open this baby up. So do any of you guys have any predictions what you think might happen when I add all three of these solutions together while I'm trying to open this? Either write it down on your paper or in the comments below and let me know what you think. So here goes our corn syrup. We're going to fill it up about probably about to here is where my goal is. So let's add this in. Oh my Lanta, can you guys see what's happening? All right. Can you guys see what's going on? So what happened with our corn syrup is it sunk down to the bottom. So now it kind of lifted that water up and the corn syrup is underneath it. So now what we're going to do, we're going to add our oil. So what I'm going to do with this, I'm going to kind of pour it along the sides if I can, so it hopefully doesn't mix as much because we want to keep it kind of 3 different layers.
Heather and Debbie both said that they think they're different densities, so they're going to layer. And Iris, age 6, thought it might get lighter, so the whole solution, when they mix together, might get lighter.
Oh, great. I love that you guys are already kind of thinking. When you make those predictions, those are called hypotheses. So you guys are actually doing some pretty high-level science right now by making those predictions. All right. So I'm just slowly pouring the oil in. So hopefully it's going to create 3 different layers that you can see very soon once I get my hand out of the way. All right. I want to leave some space at the top so I don't overflow. So might have made my water a little bit too thick. Woo. But hopefully you guys can see those 3 distinct layers. So you guys were actually very, very accurate with what your guesses were. So the corn syrup, the water, and the oil all have 3 different densities. All right, so the mass of their liquids are different, and that's what kind of separates them into these 3 different columns. All right, so my next step that we're going to do is we're actually going to add in some objects and see how their densities are kind of relating to the densities of these liquids. So I have some different objects that I have, and then I'm going to need your guys' help to determine what my 5th object is going to be. So I wrote it up here so you guys can see. I want you guys to also write these down on all the ones in red on your piece of paper because I want you to predict where you think each of these objects is going to land once I place it into my model. So my first one I have is the ping pong ball that I showed you guys before. I also have a plastic bottle cap that we're going to try. I have a wooden clothespin and the golf ball. So those are the ones that Kaya and I have chosen. But I'm going to need your help picking one of these green objects here. So I have an orange. I have a quarter. I have a plastic button, a plastic hair clip, which opens, and a Lego.
And Molly wants to know what determines where each of these objects is going to go in our model.
So, very good question. So all of these objects have their own density. So like we talked about before with the golf ball and the ping pong ball, even though they have the same volume, they have a different mass. So they have a different amount that they're going to sink down. So the same way, these layers also have different densities that might be more than some of these layers, or they might be less. So the more dense something is, or the more mass that it has in it, the heavier it's going to be. So my guess is the heavier objects are probably going to sink down further to the bottom, whereas the lighter ones might stay up to the top. So I want you guys to kind of determine which of these materials might sink all the way to the bottom. Maybe some will float, or maybe we'll have some that kind of float in the middle. I don't know. We're going to see in a second. So take a minute and write down your predictions for the objects in red, and then you choose, or help me choose, an object that is in green. So any other questions that we have so far, Kyle?
Not okay. So far. We do have one vote for the Lego afterwards so far.
Okay, perfect. Keep those votes coming in. While you guys are getting all of this set up on your sheets and sending it in to us, for those of you that are just joining, I just kind of want to do a short recap of what we're doing so you can follow along. So today we are talking about density, and we already learned that mass over volume is how you determine what density is. And we have started to create this layering effect model in our glass container. Our bottom layer is all the way at the bottom because it's the most dense. And that today is our corn syrup. The top layer is our oil. And that is the least dense, so it's floating all the way up to the top. And then we have our middle layer, which is actually just colored water, just straight from the sink. And that has a density that's in between these two layers. And that's why it's kind of looks like it's stuck in between. All right, so I'm going to put this down.
So far, we have one prediction of the original materials. Iris, age 6, thinks the golf ball is going to sink all the way down to the bottom layer.
Okay. That's a really good guess. Any other votes for what we have so far?
I've seen a couple votes roll in for the orange.
Ooh, orange. Okay. So what we're going to do, you guys keep your votes coming in for those 5 objects that were in green. I don't really have anything to... Here, we'll do this. Keep those up there for you guys so you can see. So what we're going to do is we're going to get started with the 4 that I have already chosen, and we're going to see what happens with that. So after I put an object into the container, I want you guys to observe what you see and try to tell me if your predictions were accurate or maybe it went somewhere that you weren't expecting. Science is cool stuff. Science is surprising, so it's okay if you do not get the right answer, just as long as you make a guess ahead of time, just to kind of see what you guys were thinking. So we're going to start with the ping pong ball. So it is bouncy, pretty light. So my guess, it's not going to go down too far.
Rosaria also thinks it's going to float.
Okay. Rosaria, we'll see if we're on the same page here. So 3, 2, 1. Didn't even go down a little bit. So this ping pong ball definitely floated up at the top. So record your observation on your sheet, and we're going to move on to the next one, which is the bottle cap. So this is just off of a soda bottle, so you can definitely find some of these at home. When you're trying this activity at home, you can choose any objects that you want. I just went around my house and found some things I thought would be cool to try to test. So I'd love to see what you guys test and let me know what your outcome is. Maybe send us a message or a picture with your model that you put together. All right, here goes the bottle cap. Now with this, I want to kind of make sure that it's covered in the liquid. I don't want to just put it on the top because you'll see that it'll float. But I want to make sure it's covered in the material. Hopefully can you guys see that from there? Let me move it up a little bit. Okay, so this bottle cap is actually floating right where the oil is meeting the water. So it tells me that the density of the cap is greater than the oil, but it's not as much as the water is. So that's why it's kind of stuck in that point. All right, my next one is the clothespin. So this one's a little heavier. Kyle, any guesses on this one? Where do you think it's going to go?
Well, normally I see driftwood floating, so I think it might float on top of the water. Maybe be heavy enough to sink through the oil.
Okay, that's a good guess. There is, just so you guys know, there is a little bit of metal holding it together. That might cause an effect. We're going to see. All right, 3, 2, 1. All right, can you guys see that from over there? So it actually went straight through the oil and straight through the water, and right now it's right on top. It's right here on top of the corn syrup. So maybe the metal actually pushed it down a little further than you thought, Kyle. All right, my last one that I had chosen is the golf ball. Are there any guesses on the golf ball?
A lot of people thought it would sink.
Okay.
All the way down to the bottom.
A lot of people thought it would sink all the way to the bottom. Let's see if they're correct. Oh, look at that. So it actually went down to the corn syrup, and it's a little bit into the corn syrup, but most of it is actually out in the water. And to be honest, I did not test that one ahead of time, so I had no idea where that was going. So I was guessing just like you guys. I also thought it was going to go down to the bottom. So, what is our final tally? Drum roll, please. What's our fifth one that we should choose?
It looks like most votes came in for the orange.
Okay, the orange. So, did anyone make a guess on what they thought what would happen to it?
I thought I saw one guess that it was going to float in the water.
Okay, float in the water. So, we are going to test that out. I'll probably do it on this side right now. Let me move this ping pong ball out of the way. This orange is pretty big, so we'll see. All right, 3, 2, we might have overflow here. 1, oh. Wow. So surprisingly enough, this orange is actually floating in the oil. So that's telling me that the density of this orange is lighter than even the oil that we have here today. So I want to try one more bonus. I want to try the quarter because that's the one I was secretly hoping that we were going to test. So this is metal, pretty heavy. My hope, fingers crossed, is that this is going to sink, all the way down to the bottom. Fingers crossed. Let's see what happens. I'm going to probably put it right here in the middle. 3, 2, 1. Booyah! Probably hard for you guys to see at home, but this quarter is all the way down at the bottom. So when we're looking back at all of these objects that we chose, we can see how their densities are different from each other. So the object that we had today that was the most dense was actually the corn syrup. And then the other two that were in the middle, they are denser than the top two layers, but not as dense as the corn syrup, surprisingly. The golf ball and the clothespin. And then the object that stopped at this layer here, the only one I see is the bottle cap. And then on top, our least dense object is definitely the ping pong ball, which I think is kind of right what we were all thinking. But the one that surprised me is the orange. So even though it's touching the water, because my oil layer isn't thick enough it is actually floating above the water because when I try to push it down, it floats back up. So, I want you guys to, in the comments, tell me which object was the most surprising to you. I kind of gave you guys my thoughts, but I want to kind of see what you think as well. So, you're probably thinking, Marissa, this is a great experiment, super fun and awesome, but how does this relate to Long Island Sound, the ocean, and the marine environment? So, the answer is, thank you for asking, that even though we're using 3 different types of liquids here today and creating different density layers this way, there are also thousands of density layers that are in the ocean. And if you kind of think back to what Callie and Debbie were testing on Tuesday, when they were out on the skiff, they were actually testing some of those parameters that are affecting density out there in the environment. If you have not seen their video, you can see it on our Facebook, and we also have uploaded all of these to our YouTube channel as well. So if you're a teacher and you want to share this with your students, YouTube might be a better venture for you. So what I'm going to do, I have another, I'll leave this up here for you guys. I have another quick experiment that's going to focus on one of those concepts that they were talking about the other day. So they actually used a hydrometer, which I have, let me grab it real quick. All right, so if you watched the video, you might have seen this before, but this is a hydrometer which measures the salinity of the water and the density at the same time. So you just pour water into this part right here, this whole middle part fills, and the lever is going to point to the numbers here to tell us what the density and the salinity are. So if you guys can remember, they talked about the salinity of the open ocean was about 35. And that is pretty much what I have here and here. And then I have some fresh water just from the tap as well, which are here and here. So what I want to do is I want to just quickly demonstrate to you guys how salinity can make these layers as well. So what I'm going to start with the fresh water being clear. And then this salt water, you can just use salt from your house. And I have this handy dandy pipetter, but if you want to try this at home, you can just use a straw and just cover the top with your finger. So what I'm going to do, I'm going to take my colored water, I'm going to suck a bunch of it up, and then I'm going to pour it into my fresh water, and I want you guys to see what happens. I'm going to try to put it here, so hopefully the white backdrop will help you guys see. And I'll do this a few times so that we can see what happens. All right, so here goes my salty water into my fresh water. Okay, maybe just one will be enough. So it might be hard for you to see. I'm going to lift it up a little so it's at your level. So hopefully what you guys can see is the blue water is down here at the bottom portion, and the top portion is actually still clear. So that tells me that blue salty water is more dense and it's sinking down to the bottom. All right, so there's our first. Now our second one, I already have salty water in here, and then my red water is fresh. So we're going to do the same thing really quick. All right. So go ahead, write down your predictions, what you think might happen. And 3, 2, 1. Interesting. Let it settle for a second. All right, let me hold it up so you guys can see. So this one played a little trick on me, and it seemed to have made the entire container red for the most part. It's really, really hard to see, but it is actually a little darker at the top than the bottom. So what I was hoping to see was kind of the opposite effect. So it was going to be red on the top and clear on the bottom, but I think I kind of let it go a little too fast, and it all mixed together. So hopefully if you guys try this at home, you will kind of learn from my mistake and see the outcome that we were hoping for. All right, so salinity is only one way that we create density layers in the Long Island Sound or in the ocean, and Kyle's going to show us another way. So hang on one second as we do kind of like a socially distant switcheroo. So we're going to switch around. Yeah.
All right, I'm just going to bring the camera over to this section here, and hopefully you can all see well. All right. All right, so Marissa was talking about the density of water and how salinity can affect it. Another thing that can affect the density of a volume of water or a solution of water is the temperature. The way that happens is that we remember the density equals mass over volume. Well, actually, the volume can change based on the movement of molecules and their effect and the effect of temperature on them. So when you cool something off or decrease the temperature, the molecules in that solution get kind of slowed down, and they can get tight together. So they sort of bind up and sink down. When you heat something up, they move around a lot, they spread out and expand, and that kind of makes them less dense. So cold stuff sinks and hot stuff will float usually. So in these beakers here, I'm just going to demonstrate the effect that that can have on a body of water. So these are both room temperature beakers of water, and I just put some food coloring down at the bottom carefully. This food coloring is going to represent our cold kind of bottom water. Think of like a pond, okay? And this water is basically all the water that's floating just above the substrate or the bottom of that pond. So it's kind of touching the mud down there. And that's important because in that mud is all the nutrients. And ecosystems are driven by primary productivity, which needs sunlight and nutrients in order to be productive. So the plants can use them for photosynthesis. It's basically like fertilizer. So I'm just going to drop a couple of ice cubes in one of these, and we're going to see what happens. So make some predictions about what you think is going to happen to this bottom layer of water, okay? So I'm just going to try and do it without mixing up the water too much. Now, as this ice melts, because this water is warmer than the ice, we're going to see all that bottom water start to rise up to the surface. Okay. Now what's happening is, as the ice melts, this top layer of water is cooling off and it's sinking, and that's creating kind of a vortex. So as that water sinks, the water that's down there, it gets displaced and it comes up to the surface because it is warmer than this cold water. Now, if we let this all become the same temperature, eventually this food coloring would kind of get dispersed throughout, but you can see how much of a change. Here, let me see if you can see that a little better here. So you can see how much that mixing occurs. Now, this is an important phenomenon, especially for animals that live in ponds, and this upwelling is really important because it drives nutrients from the bottom water up to the surface where there's more sunlight, and plants that float on the top or algae can use it. So this can increase the productivity of an ecosystem. Now, something I wanted to talk about is that if this wasn't the case where ice floated on top, what do you think would happen to animals that lived in a cold environment? So we talked about how if you cool something off, it gets heavier or more dense and it sinks, but ice floats. So that's kind of a weird property of water that's really important for life on Earth, because if it just kept cooling off and got more and more dense and ice actually sank, then what would be left on top is more water that would be exposed to cold air, and that another layer of ice would form, and then that would sink, and it would go on until the whole volume of water would be frozen, and anything living in there would probably be dead, right? Fish wouldn't be able to swim through it. But what actually happens, if you think of a pond that freezes over, that cold water touches the surface, and the ice starts to form, and it floats on top, and it kind of insulates the water underneath so that it protects it from the cold air above it, so those animals can survive for the winter in a pond. Yeah. So I have a couple other things real quick to show you, so we can move on here. All right. So I have 2 tanks of water. In this one is basically a body of water that is fresh and hot. And in here I have some coloring that's cold and salty. So I want you all to guess what you think is going to happen when I put this in and let it pour out into this body of water. So picture like a cold, salty current is meeting a inland sea that's slightly fresher and a little bit warmer. What do you all think is going to happen? Write it down on your papers to make a prediction, and let's see if I can get this to sink again. There you go. So I'm just going to be trying to very carefully pour this in so I don't just mix it all up, but you can see you can even get underwater waterfalls. I don't know if you can all see that here, but the cold salty water is actually pouring out and going straight to the bottom, and you can see it kind of pouring out of that little beaker in there, that little graduated cylinder, I mean. So the next one I have is the opposite. This is we're going to be introducing a current of warmer, fresher water into a body of water that's colder and saltier. So what do you think is going to happen with this one? Do we have any guesses so far? No? All right.
They're all very excited, though. I think this is awesome.
All right. So the last one kind of poured out and sank all the way down to the bottom. We'll see what happens with this. All right. So it's the opposite. You can see it going straight up to the surface and causing that mixing. So this can kind of happen when winds are driving currents in a surface currents like across a continent. So if it's like meeting the coast and going along with the coast, kind of like we have here in Long Island Sound with the Gulf Stream coming from the south to the north, that's going to drive bottom water currents up, and that's called upwelling. So it can bring those nutrients, just like in the pond that we had, up to the surface where phytoplankton and other producers can use it. So I think that's really cool, but you can see kind of like Marissa's first experiment, this just shows it a little bit more extremely. But once these currents mix, they kind of go right to where they would, and this is all driven by density.
All right.
So do we have any questions about our experiments so far?
We did not have questions. We had some comments, though. Iris thought that the blue model would spread out, and she also thought that it's kind of like an underwater volcano.
Yeah, it does kind of look like that. And actually, an underwater volcano might actually end up showing something like this one. So a hydrothermal vent or volcanic activity down at the bottom of the ocean can warm up water around those vents and basically drive those bottom waters up to the top. And then you can get mixing that way eventually, because as these currents move, they're going to be displacing other bits of water above them or below them, and that's going to make them move to take their place. So that's a really good observation, Iris. All right. Well, I wanted to thank you all for tuning in again. Make sure you check out our YouTube page so you can see other Facebook Live videos that if you missed them before. And tune in on Tuesday at 9:30 as well, and we'll have another one for you.
Bye, guys.
Goodbye.